Hey everybody, this is Larry. This is me from Q3 of the weekly contest 426. Maximize the number of target nodes after connecting trees 1. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So there are a couple of things about this one. First is that honestly, this farm is a little bit hard to read. I just spent a good time just reading this farm because I don't know, what does this mean, target to node, right? I don't know. Maybe you could figure it out and maybe you could tell me. But it took me a while and it's just like a really unnecessarily complicated way of just writing, come on, K distance away. There are already language to describe this. You don't have to invent your own Leetcode. And especially writing in a way that is, I don't know, why is this, like this feels like it should be a verb, but it's a noun maybe, and it's very weird that it is bold, like, would you really bold an action? I mean, maybe specific, I don't know, it's very weird. Everything feels very weird about this farm in terms of reading. Anyway, after you finally read this farm correctly, which took me a bit, it's just figuring out that, okay, you have two trees for each node in node 1, in tree 1, sorry. With each node in tree 1, if you connect a tree from, or connect it to a node in tree 2, what is the, how many nodes are K or fewer distance away, right? And that, it turns out that this one is just greedy because and I do like that. I don't know if I like it, but I do see, you know, what they did with this explanation where they kind of fool you on choices, but there really is no choice. I mean, or the choice doesn't matter, right? Because if a node on tree 2, because you connect one edge, it's going to be K minus one edge, right? Because you connect one edge, it's going to be K minus one distance from the new contribution of tree 2. Right? So in that sense, you always want to greedily choose the one that gives you the most nodes added, because you're trying to maximize a sum function between A and, like, trying to maximize A and B. Well, B is going to be the same for every node on edge 1 or in tree 1, so you can just maximize that. So okay, so that's out of the way. And then the second thing is that n is only, or NNM is only 1,000. What that means is that, okay, well, you don't even need anything too crazy with respect to distances, right? Because you can just do a naive n square, either breadth first search or depth first search. It doesn't matter because it's a tree. And what that means is that there is a unique symbol path between every two nodes. It will take all of n to run through a depth first search or a breadth first search, but because n is only 1,000 and m is only 1,000, 1,000 squared would be, you know, pretty straightforward. No, you know, right? Like, it's fast enough is what I mean, and you should be familiar with those complexity, and that's pretty much it. With all that together, so I think one thing that you can work on your speed about is noticing the common pieces. And I kind of maybe didn't do it here. Maybe I could have done this with even, like, you know, get adjacency list of edges, right? So then I could maybe have done this in a real quick something like this. Then now I could do. I could write E1 is equal to get adjacency list of edge just 1, and E2 is equal to so this part I probably should have done, right? And yeah, and this just gets the, you know, converted to adjacency list. But for search, again, you want to reuse as much as possible, so that's why this is funky. But what I have is that X is the starting node, E is the adjacency list, N is the number of nodes, and K is the distance, right? And the reason why that comes up together is that R max, we set it to 0. I forget why I said R, but for the second tree, like we said, we can greedily choose the node that gives us the thing, because it doesn't vary depending on the node that you connect it to. So then here, we just do for I loop through M, and then we just brute force getting the max one, right? And this is just I, the second adjacency list, M, and K minus one, because you have to connect one edge to make it K minus one. And then, yeah, on the left side, so this is on the second adjacency list. On the first one, that's the one that you just kind of, brute force, or check every number, which is that you can do with a breadth first search, plus or max. And that's pretty much it. Oh, I mean, I didn't go with the breadth first search too much because this is a very standard breadth first search. I have the distance, I have a queue, I set the initial distance to 0, I put it on the queue, and then this is just regular breadth first search stuff. Just one node at a time, creeping in terms of frontier, if you will, and then we just count the number of things less than or equal to k. Remember that this k is not it's not the general input k. It's specific BFS k, so that we could differentiate between k minus 1 and k. So yeah, so I think like the biggest thing about this one is about writing clean code almost, because then now you kind of fit everything together in a way standard way. I'm gonna make it smaller so you can see everything on screen, hopefully. I guess not because of my comments. Okay, fine. Right, maybe not then. But okay, then here's the top. I mean, it's mostly there, but yeah, and then the bottom. And I spent a good amount of time reading this problem. That was why it took me a little bit longer than I would like. And also I just got, and I wrote this as equal to that minus 1 instead of plus 1. So it was giving me other errors because I'm a silly boy. But yeah, but that's all I have with this one. This is O of M in terms of the iteration in the loop. This BFS is also O of M. So this is going to be M squared total. Same logic is that this is O of N. This is also O of N per loop. So this is N squared for this loop. So it's going to be N squared plus M squared. And that's pretty much it. That's the complexity. That's all I got for this one. And yeah. For space, we really only need space for the adjacency list. And also this one's O of N plus M for both things. So that's pretty much it. O of N plus M, let me write it out then. N plus M space. And that's pretty much it. That's all I have for this one. Let me know what you think. Thanks for watching. And you could watch me solve a live in contest next. A negative number thing. Alright, well if I get another wrong answer, I'll just be very sad. Okay. I rushed it though. I am rushing it too much. Trying to like time trial this. Okay. Focus, finish. Let's go. Okay. Honestly, some part of the reason is because I cheated a little bit. I saw that someone finished in 7 minutes, so my mental pacing is off, and I rushed myself, and I gotta slow down, Larry. Slow down. Okay. So you have 2 trees, nodes. Okay. So okay, fine. Right. Node U is target to node V if the number of edges. What? Node U is target. That's not really. What does that mean? Are these words? Okay, so you have 2 trees. Return an array n of an answer as a number target. What does target mean? It's not a real word. Node U is target to node V if the number of edges on the path from U to V is less than or equal to K. Okay, so it's basically like a distance thing, but it's still like a very awkward phrasing. Okay. Number maximum. Okay, so you have. Okay, fine. Independent. It's divided as the max possible number of nodes target to node I on the first tree. If you okay, maybe. I'm still like tilted by that 6 minutes answer, so maybe I need to slow down. Okay, so you have this tree and then tree 2. The I is equal to 0. Connect node 0 to the node 0. I mean, this is just greedy, I think. Wait, is it? Yeah, I mean, I think this is just... No, but then here, connect node 2 from the first tree of or on the second tree? No, it's still, oh no, I think this is still greedy. It's just that they kind of try to do it to mix you up, because basically k is equal to 2, 4 has 1, 2, 3, 4, 5, and then 0 has 1, 2, 3, 4, 5. So I think that's just a lie. So you just basically get the, oh, and okay, so this doesn't allow us to do n square things. So I should have, for some reason I thought that it would be like a 10 to the 5th linear thing. I gotta look at the constraints. I am not in shape for today. But okay, so what am I doing? Shortest path for each node. Yeah, okay, yeah, what am I doing? Yeah. Yeah, this is just typing at this point. And then now m is equal to the number of edges 2, but it's a tree, so the number of edges is this plus 1, right? I always, v is equal to e plus 1. No, it's the other way. Okay, so then now, whatever. It's also a tree, so you could do a depth first search, but yeah, whatever. I already voted it. Voted this way. Yeah, whatever. Why am I so bad today? That's not right. Also, this is too hard. Okay, fine. Keep it this way. Okay. Yeah. Okay. Whatever. I could probably pre-filter prune this, but whatever. And if it times out, I'm just gonna say it's because Leetcode sucks. What is it? Max less than, or you got a number of edges. So if you're one distance away, you're one. Okay, fine. So yeah. Actually, it doesn't even need to be this way. It should be. I don't know what R means, but. Okay, and then now, oh yeah, that's weird, but okay, fine. And maybe this could have been a library, or not library, but a helper, whatever. BFS I E1 N plus R max. something like that. Making a lot of silly mistake today, so okay. At least this is good. T. Am I messing this up? G1. Oh, jeez. Maybe there's some like weird shadowing thing. Oh, that's why. That's why. Well, okay, maybe there's another reason why, but we'll do. Do I not know how to write a breadth first search? The answer is apparently. At least one index? No. Why? I don't know how to write a breadth first search. How did this happen? So 7 crashes. Am I misreading something? I am just bad at math or coding. Okay, that's fine. Okay, that's actually very wrong. Is it the max? We said max, right? So what is going on here? Well, lucky I wasn't here for the actual contest, I guess. Yeah. Okay, so the max is 7. Is that right? Can be right. 0, 1, 2. K is less than. K is 2. 0, 1. This no, that should be right, but 7, 0. 1 is the closest to stuff. 1, 2. That's true, actually. I misunderstand this problem. Maybe I rushed this one. Why would you not connect to node 1? Oh, it's -1. It's K minus. Ooh. I see. Because you have to. Okay. Silly Larry. That's actually okay. An obvious-ish thing, but nonetheless, not obvious enough for me to not make a mistake about it. Watch I get another wrong answer. Okay. And then 1,000 people have gone. Oh, is this the same problem? Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem, this contest, everything in between, the explanation, maybe not. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.